All right, this is our last day of notes in terms of what we are talking about with factoring or solving our different quadratic equations. We'll talk more about what this solving means for us as we move forward in the rest of this chapter. But today we're going to talk about using all of our different methods that we have. So we're on day 5 in chapter 6, talking about all of these methods of solving quadratic equations. And so the first thing that I want to note is just a reminder for you that when we have our equations, we'll usually see them in standard form, which is ax squared plus bx plus c. And that'll be equal usually to 0 when we have them all together, but sometimes we'll have them on different sides of the equation depending on which way we're trying to solve this. But just as a note, when we're talking about a, that's the number in front of x squared, and when we're talking about b, that's the number in front of plane x. And so we have our different ways that we can factor things. So if you're going to use a factoring method, well, the equation has to be factorable. Oops, equation is factorable. Now that means that we can use that x method where we multiply on top, add on the bottom. You might have to slip and slide maybe to get it so that it's factorable. But regardless, this would be the same as a couple of days that we've looked at in the past. If you wanted to review, you could always use that day 1 couple of pages that we had. So this was day 1. And there were 2 pages for day 1, so keep that in mind. Those would be our factoring types. Then we have, if we want to solve something by using the square root method, or if we can use the square root method to solve something. When we use the square root method, there is no bx. There is no middle term, meaning that our equations would just be something of the form 16x squared equals 9 or something like that. There is nothing that has just a plain x with it. And so for these ones, you would simply get x by itself. There's really no factoring for this one. Nothing extra that you have to do. We just want to get x by itself, solve your equation like you normally would. But for completing the square, there are some different times when completing the square is easiest. It's easiest to do the completing the square method when a is equal to 1, so that's the number in front of x squared. If there is no number up here, then we can use this method, and it'll be an easy way to do it. But we also need b to be even, if b is even. And so if that's this middle term, and we need that because to do the completing the square, we're going to take b divided by 2 and square it and add that to both sides of our equation. And then we'll end up with some factor x plus 2 squared is what our quadratic would end up being factored as. And if we want to use the quadratic formula, well, you can use that for anything. We can use this for all cases. But for the most part, we'll want to use this when none of these 3 things here apply. And so the other thing you might be thinking of, well, gosh, when do I know when something is factorable, or how do I know if something is factorable? There's this thing that we call using the discriminant, and we'll talk more about that in the future. But an equation, the equation is factorable if the discriminant which we use the equation d equals b squared minus 4ac, if this is a perfect square. All right. And so that's a quick method that you can use to say if something would be a factorable equation, if you can just use one of our factoring methods that we talked about in Chapter 5 and be able to solve using that. Otherwise, though, you might want to look back at some of these other days as well. So I'll fill that into, we talked about square roots and completing the square in day 2. Completing the square was both day 2 and day 3, though. We did that for 2 days. And the quadratic formula was our last day that we did, day 4. Remember that the quadratic formula, negative b plus or minus square root of b squared minus 4 times a times c, all divided by 2 times a. And you can look back in that day 4 notes page if you want that as well. So anyway, we are going to do a couple of these 4 examples that are down here. So let's see. I'll just start with problem number 1. So for problem number 1, we'll want to decide which method we're going to use, and we can use these little boxes over here to say which method we're going to do. If we're going to factor, square root, complete the square, or quadratic formula. So there's a couple of things that I noticed first. I noticed first that there is a bx. There's a b term. So I know that I can't use the square root method because it can't have a bx. But I also notice that a is 1. There's no number in front of x squared. So that means that 1 is in front of x squared. And b, this middle term, is even. Negative 6 is even. So that means I could use the completing the square method, but let's get everything all over to one side first. So I'm going to subtract 73 from both sides. That's left and right of the equal sign. And so my equation would say x squared minus 6x minus 67 equals 0. And so what I'm going to do now is I'm going to use this discriminant to see if this might be a factorable equation. So to do the discriminant, I'll just do that off to the side here. For the discriminant, that's b squared minus 4ac. And since I have b, a, and c, I want to label those, find those from my equation a, b, and c, so that I can plug those all in. We already said that a was 1, b is negative 6, and c we just made is negative 67. So we'll plug all of those in. Negative 6 is b, a is 1, and times negative 67. Now, I don't even really need to do this multiplication to know that this is going to be a larger number, so I'm going to grab a calculator. And so we want to use this to just double check that we do have a perfect square here. So 6 squared is 36, and negative 4 times negative 67 times 1 is 268, so plus 268, and so I'll add on that 268 with 36, and I get 304. Now, if you don't know if this number is a perfect square, a quick check is to just take the square root of it. So to get the square root, you'll notice that it's right here with that square button, but it's in the blue text. Oops, there we go. It's in the blue text above the x squared button. To get that, we're going to take this second button and then press our x squared button. And that gives us the square root of our calculator, and 304. You see that we get a long decimal, meaning that this equation cannot be factored. So we're going to use that completing the square method. To complete the square, we said that we want to get x's by themselves. So I want to get whatever's over here to the other side of my equation. So I'm going to add 67. I know that we just subtracted 73, but regardless, we would have had to do some extra work up here anyway. So now my equation says x squared minus 6x equals 67. And because we're completing the square, I'm going to leave a space here because I'm going to add a number to both sides of my equation. To find that number, we take b divided by 2 and square it. So negative 6 divided by 2 squared which would give me negative 3 squared, which means I'm going to add 9 to both sides of my equation. So plus 9, plus 9. And so on the left side, we'll know that we want to factor this because we made it a perfect square trinomial, so we're factoring it into something squared. And that factor that it works with is that middle number that we had when we were figuring out what to add. So I have x minus 3 as my squared factor. And then 67 plus 9 would give you 76. So now that I have something squared, I want to get x out of being squared because the whole goal is to get x by itself, no matter which problem we're doing. It just depends on how the steps go to get it by itself. And since I have x in these parentheses squared, I'm going to take the square root of both sides. So I'll have x minus 3 equals plus or minus the square root of 76. And so we'll want to list the factors of 76 just to make sure that we don't have any perfect squares in there. So we've got 1 and 76, 2 and 38, 4 and 19, and I do believe that that would be it. There are no perfect squares that are factors of 76, and so we would be able to just leave this as square root of 76 with that plus minus. Now I still don't have x by itself. This is x minus 3. So to get x by itself, I'm going to add 3 to both sides. And the more appropriate way to write this final answer is to have x equals 3 plus or minus the square root of 76. You can put that in curly brackets if you like, but either way that would be our solution. Now, let's talk about another example that we could have. We could have an example here like number 3. So if we have a problem like number 3, there's a couple of things we notice right away. First thing is that we notice that we have 3 terms. We have x squared, x, and a plain number, even though they're separated right now. Since I have an x in the middle, I know that I can't use the square root method because I can't have that x term if that was the case. I also know that since I have something in front of x squared, well, completing the square said the only thing that can be that a term, or the thing in front of x, is 1. Since it's not 1, I know that completing the square is probably not the easiest way to solve this one. The only other thing to check is to see if factoring this wouldn't be easier. So we're going to use that discriminant again, this equation right here. And so a is 2, b is 8, and if we subtract 3 from both sides, we would have c is 7. So we'll plug that in quick. 8 squared minus 4 times 2 times 7. And so we've got 8 squared is 64. 4 times 2 is 8 times 7 is actually 56. And 64 minus 56 would give you 8. Now, the key is, if we're going to use that discriminant to decide if something is factorable, it needs to be a perfect square. And 8, I hope you would all say, is not a perfect square, so we can't factor this one. So instead, we're going to have to use that quadratic formula. So we already kind of figured everything out here. So our equation, let me just rewrite this from when I subtracted that 3 over. Because if we're going to use the quadratic formula, we need everything all together. And so I've got a is 2, b is 8, c is 7, and we'll plug those into our formula. X equals negative b plus or minus the square root of b squared minus 4 times a times c. Hey, do you notice something? Notice that when we looked for the discriminant, that was b squared minus 4 times a times c, which is the same thing as what's in our quadratic formula. Maybe you noticed this when I had brought it up, that sounded familiar, but it's actually the thing that's inside of our square root. So since we've already done that part, we don't need to do that extra solving for our calculator. We already know it. and then 2 times a, which is 2. And so as we said, we found that discriminant piece was 8, so in our square root, we'll still have 8. And negative 8 doesn't change, it's just negative 8. And 2 times 2 would give you 4. Now we're still not quite done. We would want to simplify that square root of 8 down and then simplify our fraction more if we can. So square root of 8, factors of 8 are 1 and 8, 2 and 4. And if I want to simplify a square root, I want to pick its biggest perfect square, meaning that the square root of 8 would be simplified to square root of 4, square root of 2, and the square root of 4 is 2. So square root of 8 is the same as 2 square roots of 2. So negative 8 plus or minus 2 square roots of 2, all divided by 4. And hopefully you all notice that all of these things outside of my square root are even. So I have a negative 8, a 4, and a 2. And I can take 2 out of all of those things. 8 divided by 2 would give me 4. 2 divided by 2 leaves me with 1. And 4 divided by 2 is 2. So my final answer would say that x equals negative 4 plus or minus the square root of 2, all divided by 2. Again, if you have plus or minus the square root, you do not need to write those as 2 separate answers. They can be just one answer together. So if you wanted to, you could try 2 of these examples here. However, your goal for the day is to do 2 examples here on the flip side of your page for today. Again, use a calculator when you need it. It's okay to use that for different multiplications and things because some of our numbers get to be a little crazy, especially when we start using that quadratic formula. So do 4 problems, come back and check in with me, and I'll see you in a few.